Hello friends, welcome to Learner's Planet. Friends, this is our first session for the topic straight line. You might have attended the basic session of coordinate geometry, and I'm sure you are clear with the basic concepts of coordinate geometry. Like you must be knowing the distance formula, you must be knowing the section formula, that is internal external division, and some more, right? And if you haven't attended the basic session of coordinate geometry, do attend that before you come for this session. Okay, so here we start a straight line. Now let's begin with a definition. The straight line is a curve such that every point on the line segment joining any 2 points on it lies on it. Precisely, it is a combination of so many curves, and the curves are so small that we feel them as a straight line. Okay. The simplest locus of a point in a plane is a straight line. A line can be determined uniquely by any one of the following conditions: two different points and a point in a given direction, right? See, you must be knowing from these 2 points, from the two fixed points, only one line can pass. Then unique line through a given point with a given direction, right? This angle is 45 degree, and in this direction, when the angle is 45 degree, through a particular point only a single line can pass. Similarly, infinite number of lines can pass through a given point. Here we can see origin, and so many lines are passing through origin in different directions, right? And infinite number of lines can pass in the given direction. See, all of these lines are making 45 degree angle with OX axis, right? But all of them are passing through different points, right? So if direction is same, points are same, then there will be a single line like this. If direction is same but points are different, then there may be infinite lines. Okay. Now we have seen all these figures, and it's very clear that infinite lines can pass through a point or are in the same direction, right? So if we wish to determine a line uniquely, two geometrical conditions are required. Let's discuss the two geometrical conditions. That is slope of a line. The trigonometric tangent of the angle that a line makes with the positive direction of x-axis in the anti-clockwise sense is called the slope of the line. Here this is slope of the line. This is positive direction of x-axis, and we have to go anti-clockwise direction. Okay, so this is nothing but the slope of the line. Similarly, over here this is slope of the line. Okay, then, and this is actually angle, and tangent of this angle is will actually be slope, right? The trigonometrical tangent of angle that a line makes with positive direction is known as slope. So slope, this angle is 45 degree, that means this inclination is 45 degree, but slope will be 1045 degree. Okay. Now if theta is the angle at which a straight line is inclined to the positive direction of x-axis, then tan theta is called the slope or gradient of the line, and where this theta is between 0 to 180 degree. Okay, and it's very important that you need to take the direction as anti-clockwise. Okay, now suppose you wish to find out angle of this, right? Maybe slope of this line. So the slope of this line should be calculated from this side, right? This way. So it will definitely it will be more than 90 degree. If you take it from this side, it will be less than 90 degree, right? So the calculation of slope will be wrong, right? So you have to take the direction from the positive direction of positive side of x-axis, and direction should be anti-clockwise. Okay, that's really important. The slope of a line is generally denoted by m, and actually m is tan theta. Basically slope is tan theta, so, and the slope is denoted by m, that means m is equal to tan theta. Slope of a line through the points a x1 y1 and b x2 y2 is y2 minus y1 by x2 minus x1. That means difference between ordinates and difference between abscissa. Okay. we'll see the derivation of this, so not to worry about it. As of now, just keep this thing in mind. The slope is nothing but the difference between ordinates by difference between abscissa. Okay. Now we see how do we find out the slope of a line that is passing through 2 points. Here it is passing through 2 points A and B, x1, y1 and x2, y2, right? Now you can see this triangle, and this triangle, all the three triangles are similar to each other because this line is parallel to this line, right? So suppose this angle is theta. Okay, slope of this line will be what? It will be tan theta, right? If this angle is theta, this will also be this angle is theta, then this will be theta and this will also be theta. Okay, now I extend this line and I have this triangle BA and I suppose this is say L, right? I have this triangle. Now in this triangle, this angle is theta. I'm just considering this triangle. Okay, this angle is theta, right? And this line is passing through 2 points x1, y1 and x2, y2. Now according to trigonometry, tan theta will be what? Perpendicular by base. Now perpendicular is this length, right? This length. Now this length, how can we calculate? From this point to this point minus from this point to this point. So the total length from this point to this point is nothing but y2, right? This total length is y2, and from this point to this point it is y, right? That is this length. So from this point to this point it is y1. Okay, so that is perpendicular and by base. So from this point to this point the total length is x2, and from that if I deduct the length from this point to this point, that is actually x1, I'll be able to get this length. This length is actually same as this length, right? So total length minus this length, right? Coordinates of A, x1, y1, that means this length is x1 and this length is y1. Okay, so tan theta is equal to y2 minus y1 upon x2 minus x1. That is the slope of the line passing through 2 points. We can say tan theta as m also, right? So precisely y2 minus y1 is equal to m x2 minus x1. This is the equation of a straight line that we'll discuss in detail later on. But as of now, tan theta or slope of the line is clear to you. Okay. Now we see the different forms of straight lines. The first is, the very important one, is slope intercept form, right? Equation of a line whose slope is m and which cuts an intercept c on y-axis, that is it passes through point 0c, is given by y is equal to mx plus c. Now how do we do that? So this is the length of intercept. Okay, this point is nothing but 0c. That means x coordinate is 0 and y coordinate, the value is c. Now I draw a line parallel to x-axis. Now I just complete the triangle. Okay, now you can see this triangle is similar to this triangle. If this angle is theta, this will also be theta, right? So according to the previous calculation, then tan theta is what? Perpendicular by base. So for this triangle, perpendicular is what? This length. The total length is what? Y. This length is what? C, because this length is C. So the total length, I assume this point to be x, y, right? So this is xy. So the total length is y. Out of this, if I deduct this length, that is actually C, that is the length of intercept, I'll be getting the length of the perpendicular. So that is y minus C. Okay, divide by the total, this length, right? If the coordinate of this point is x, that means this length will be nothing but x. Okay, same as this. Okay, so it is y minus c by x. Tan theta is actually m, so if you cross multiply this, you'll be getting y is equal to mx plus c. That is the slope intercept form, right? Why do we call it as a slope intercept form? Because we have slope over here and we have intercept over here. So if we know slope of the line and its intercept on y-axis, we can make the equation of line, right? Only two unknown things are there, right? M and c. Okay, so if you know m, if you know c, you can make this equation of line. Okay, so that is slope intercept form, and that's really important. Now we try this problem based on this concept. Small slope intercept form. A straight line makes an angle of 135 degree with x-axis and cuts y-axis at a distance of -5 from the origin. The equation of the line is, okay, tan theta, here theta is 135 degree, right? So slope will be m is equal to tan 135 degree, that is tan 90 plus 45, or we can say minus cot 45, that is -1, right? So slope is -1. Then intercept is -5, that means c is equal to -5. Now you know intercept, you know slope. You can construct the equation of line. Y is equal to mx plus c. Now y is equal to m is what? -1. And what is c? C is -5. Okay, so it is y plus x plus 5 is equal to 0, or we can say x plus y plus 5 is equal to 0. Okay, so this one. I hope you are clear. Now next important form is a point and slope form. The equation of a line passing through the point x1 y1 and having slope m is given by this. Now how do we find this? See here, in this case we just know that line is passing through just one point x1 y1, right? So we don't know the value of x2 y2, so our problem is starts from x1 y1 only. Okay, so this line is passing through x1 y1. Again this line is making a slope. The slope is actually tan theta, so I assume this to be theta, right? Obviously it is the slope is theta, so it will be, the slope is tan theta, so this angle will be theta, right? Now we take this triangle, okay, and we can also say this triangle is similar to this triangle because this line is parallel to this line. Okay, so if this angle is theta, this will also be theta. Okay, so now we take this triangle, this angle is theta, so slope will be tan theta, that is m, is equal to perpendicular by base. Now what is perpendicular? The total length, that is actually y, total height of the line is y minus this length, right? So we'll be getting this length. Okay, so total length is y, from that we deduct this length, that is actually y1, by this, from this point to this point the total length is x1, I'm sorry, x, and from this if we deduct this length, this is actually x1, then we'll be able to get this length, and this length is equal to this length. Getting my point? So we are finding out the dimensions of this triangle PAQ. The total height is y, from that we are deducting this height, that is y1, so we'll be able to get the length PQ, so that is y minus y1. Similarly the total length from this point to this point is actually x. Okay, from that if we deduct this length, that is this length. Okay, so that is x1, so x minus x1. So m is equal to y minus y1 upon x minus x1, or we can say y minus y1 is equal to mx minus x1, right? So if you know a slope and if you know the slope of the line and the line is passing through point x1 y1, you can make the equation of the line, right? So that is point slope form. So in the previous derivation we learned that y is equal to mx plus c, right? So this is actually slope intercept form. If you know slope, if you know intercept, you can make the equation of line. If you don't know the intercept and if you know the slope and the one point from which the line is passing through, then also you can make the equation of the line. Okay, so two forms we have discussed. Now the third one is 2-point form. Friends, we have already calculated the slope when the line is passing through 2 points x1, y1 and x2, y2, right? So slope was y2 minus y1 by x2 minus x1, right? So if we put the value of this slope over here, right, precisely that is nothing, y2 minus y1 is equal to mx2 minus x1. Okay, value of this, if we put up in point slope form, that is y minus y1 is equal to mx minus x1. That is point slope form that we have already discussed. So y minus y1 is equal to mx minus x1. If I put up the value of m as y2 minus y1 by x2 minus x1, I'll be getting two-point form, because we require 2 points x1 y1 and x2 y2, right? So if we know the 2 points from which the line is passing through, then also we can make the equation. So we got the three methods, right? Point slope form, 1-point form and 2-point form, right? So all the three are very important. We'll be using them while we'll be solving the problems, right? So if you know point plus slope, you can find out 1 point plus slope, then you can find out the equation of line. If you know 2 points, then also you can find out the equation of line. The third is if you know slope plus y-intercept, then also you can find the equation of the line. So there are three methods, right? This 1-point form, this is 2-point form, and the third one is slope intercept form, that is y is equal to mx plus c. So I'm just revising them again. 1-point form, 2-point form, we require 2 points over here. Here we require 1 point and slope. Here we require 2 points, and here we require slope and intercept, right? So three major type of lines are there, major forms of lines are there. Okay, now the next is intercept form. The equation of the line which cuts off intercepts A and B on x-axis and y-axis respectively is given by this. Now if it is cutting x-axis at the point A, that means this length is A and y coordinate will obviously be 0. Similarly on y-axis, this length is B and x coordinate will be 0, right? Now we know the line is passing through these 2 points, 0B and A0, and we have already derived the formula for the line when it is passing through 2 different points. So what will be the slope? M is equal to y2 minus y1 upon x2 minus x1, right? Suppose this is x1 y1 and this is x2 y2, whatever you can assume, that really doesn't matter. So y2 minus y1, that means 0 minus y1 by a minus 0, 0 minus b upon a minus 0. So slope is equal to minus b by a, right? Now we know the slope. We have to write down the equation of the line. So y minus y1, that is b, is equal to m x minus x1. Okay, y minus y1 is equal to m x minus x1. Okay, so m we have already calculated, minus b by a. Now what you can do is ay minus ab is equal to minus bx plus 0, right? So ay plus bx is equal to ab. Okay, if you divide this left hand side and right hand side by ab, you will be getting ay by ab plus bx by ab is equal to ab by ab, that means 1. That means x by a plus y by b is equal to 1. So friends, when you know x and y intercept, directly you can frame the equation of line, right? X by intercept on x-axis plus y by intercept on y-axis is equal to 1. So directly you can use this relation. Okay, and I have also shown you the derivation of the same, so that's pretty easy. Let's move. Now the next important thing is the angle between the two lines, right? Suppose we have these two lines, one is this and other is this, and we are interested in finding out the angle between these two lines, this line and this line, right? Suppose slope of this line is we can say m1, or that is 10 theta 1, right? And slope of this line, that is m2, that is 10 theta 2. Okay, and angle between these two lines is nothing but we assume that is theta. Okay, now if slope is m2 is equal to 10 theta 2, that means this angle must be theta 2, but this angle must be pi minus theta 1, because we take slope from positive direction of x-axis, right? So this angle is actually theta 1, that means this angle must be pi minus theta 1. Now all these three, that is theta plus theta 2 plus pi minus theta 1, should be pi, right? 180 degree. Okay, because the sum of the three angles of the triangle should be 180 degree. That means theta is this is theta, this angle, that is theta plus theta 2 plus pi minus theta 1, right? This angle plus this angle plus this angle. So theta plus theta 2 plus pi minus theta 1, that should be equal to pi, right? So pi and pi is cancelled. That means theta is equal to theta 1 minus theta 2. Okay, theta is equal to it will go right hand side, theta 1 minus theta 2. That means 10 theta will be equal to 10 theta 1 minus theta 2, right? Now 10a minus 10b, what will be the formula? 10 theta 1 minus 10 theta 2 upon 1 plus 10 theta 1 10 theta 2. Okay, 10 theta we can write it as m, that is the angle between the 2 points, or just 10 theta, that is 10 theta 1, that is m1 minus m2 upon 1 plus m1 m2. So it is actually very important. Okay, that is the angle between the two lines when the slope of first line is m1 and the slope of the other line is m2 is given by 10 theta is equal to m1 minus m2 upon 1 plus m1 m2. Now the next interesting part, right? Angle between two lines is given by 10 theta is equal to m1 minus m2 upon 1 plus m1 m2. Now if the two lines are perpendicular to each other, right? If the lines are perpendicular to each other, that means theta will be 90 degree, right? The angle between the two lines must be 90 degree. That means 10 theta will be 1090, and 1090 is what? 1 upon 0, right? That is infinite. That means 1090, that means the denominator is 0, that means 1 plus m1 m2 is 0, right? If the lines are perpendicular, 1 plus m1 m2 will be equal to 0, that means m1 m2 is equal to minus 1. An essential condition if the lines are perpendicular to each other, right? Or you can say if the lines are perpendicular to each other, product of their slopes must be minus 1. Okay, so when two lines are perpendicular to each other, that means angle between them, that is theta, that is 90 degree, that is this angle must be 90 degree. If theta is 90 degree, 1090 is 1 by 0, that means denominator must be 0. So 1 plus m1 m2 is equal to 0. The second condition, if the two lines are parallel, if the lines are parallel, then slope is always same. Okay, if the lines are parallel, slope is same. That means m1 minus m2 should be 0. That means there is no angle between these two. See, between these two lines, the lines are parallel, there is no angle between these two, right? That means theta is 0. So if 10 theta, that is 10 0, that means 0. That means m1 minus m2 is 0. That means m1 is equal to m2, right? So this is the essential condition for perpendicularism, and this is the essential condition for parallelism. If the two lines are having an angle theta between them, then 10 theta is equal to m1 minus m2 upon 1 plus m1 m2. That means there m1 and m2 are slopes of individual lines, and if the lines are perpendicular to each other, theta will be 90 degree. Tan 90 is not defined, that means denominator is 0. That means 1 plus m1 m2 is 0. That means m1 m2 is equal to minus 1. Right? If the two lines are parallel, that means the angle between the two is 0. That means tan 0, that is equal to 0. That means numerator is 0. That means m1 minus m2 is 0. That means m1 is equal to m2. Right? So if the two lines are parallel, the slopes will be equal. If the two lines are perpendicular to each other, product of their slopes must be minus 1. So this is really important. Okay, so in this session we discussed the various forms of lines, and we discussed this very important relationship. Okay, in the next session we'll be taking the problems on these basic concepts. So do revise this session, and yes, you should be clear with the basics of coordinate geometry. Then only you will feel this straight line topic to be very easy. Okay, so I'll see you in the next session once again. Bye bye.